Why?
It's been a lot of people.
Okay. How's it going?
Hi.
Hi. So today we're going to talk about derivatives of trig functions. So, suppose we wanted to find the derivative dx of sine x. Right? So we know that we would have to do this limit thing. So this would really be equal to the limit as h goes to 0 of sine x plus h minus sine x over h. Right? That's the way you calculate derivatives, right? We have these shortcuts for powers and stuff like that, but in general, they're all derived from this little formula right here. So if we wanted to figure out like how to simplify this to get like something a little bit nicer, let's do a little trip back in time. So remember, when we were talking about limits, we actually calculated a couple of special trig limits, and the special trig limits were, there was 4 of them, but 2 of them were the limit as x goes to 0 of sine x over x equals 1. Do you remember that one? Vaguely, maybe, not totally foreign.
Yeah.
Okay, and then there was another one that said the limit as x goes to 0 of cosine x minus 1 over x equals 0.
This is the day we spent like 10 years like arguing with you about like how to cheat the system, right? Yeah.
Wait, what?
We spent like the entire period being like, oh, but if you do like weird backwards math, it does this, and you're like, no.
Oh yeah. But these were the basic rules for that, right? Do you remember? Like these were the basic things. Okay, so if you kind of remember those basic special trig limits, there's actually a sort of obscure thing in trig called the what do they call it? I don't even know. The angle sum identities. That's what they're. Okay, and one of these angle sum identities says if you have the sine of a plus b, where a and b are any angles, this is actually equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. Okay, like if you guys remember doing those in trig last year? Not very much, maybe.
No.
Okay. Well, this is always true. Like if I were to take any 2 angles and plug it in here, and take the same 2 angles and plug them in here, they're equal to each other. Okay, so that's what I have here. I can rewrite that using this trig identity. So the limit as h goes to 0. This would be the sine of x times the cosine of h plus the cosine of x times the sine of h minus sine x. So this whole thing right here is really the same thing as sine x plus h. Now, 2 of these have a common term. Like if I look at this one, it contains sine x. And if I look at this one, it contains sine x. So what I could do is I could just take this term and factor out a sine x out of those 2 terms. Okay? So this would end up being limit as h goes to 0, sine x times cosine h minus 1 plus cosine x sine h. Everybody see the algebra I did? I just took a sine x out of here, which left me with cosine h, and I took a sine x out of here, which left me with -1. Okay? And then I could split this up into two limits. The limit as h goes to 0 of sine x times cosine h minus 1 over h, plus limit as h goes to 0 of cosine x sine h over h. Because this fraction, a plus b over c, you can split it up to be a over c plus b over c, right? And then, if you look at what our memories told us, it said that the limit of this expression is 0. Well, I have that right here. Cosine h minus 1 over h. That's 0. And if you look at this limit, the limit of sine x over x is 1. I have that right here. This is really 1. So this ends up being 0. And this ends up being cosine x. Because if this part of it's 1, there's no h's left. So there's no place to substitute it. H equals 0, and you just have cosine x. So the derivative of sine x is cosine x. The actual work there, you don't have to know how to do all that stuff, but I just wanted to show you as sort of like a proof, sort of. But now that I did it, I feel like it was a little more in the weeds than I was intending to go. So anyway, so the derivative of sine x is cosine x. Derivative of sine x is cosine x. There's 5 other trig functions. They all have derivatives too. The derivative of cosine x is negative sine x.
It's the derivative of negative sine x. Negative.
Yeah, that's the constant multiple rule, right? If you have a constant times a function, then you can just carry the constant down to the next thing. Cool. Derivative of tangent x is secant squared x. And again, if you're wondering how this is, it's like, goes back to this, actually.
It's this thing again.
Yeah. With minor changes. Which, remember, with this notation, secant squared, this is really the same thing as secant x squared. Right? This is just the same notation for that, or a different notation for the same thing. The derivative of cotangent x is negative cosecant squared x. Which is negative cosecant x squared. Two other trig functions, secant and cosecant. So the derivative of secant x is secant x times tangent x. And the derivative of cosecant x, maybe we can figure this out. There's definitely a pattern here. Maybe you noticed it, maybe you didn't, but like the derivative of sine is cosine, the derivative of cosine is negative sine. So it's the negative, and then it's like the co-function.
Right.
Here, it's the same pattern, right? Derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared. So I made the negative and I took the co-function. So using that same pattern, what do you think this derivative should be? Negative.
Right.
And then what? Cosecant x times cotangent x. And that's exactly it.
Okay.
So really, although it looks like 6 totally different rules, you really, if you know 3 of them, then you know the other 3 because there's a pattern. Okay?
Okay.
Now this is open note, of course, right? So you don't have to memorize anything. So, but that's it. Now, if you had some combinations of these, like you treat them just like you would any derivative rules. Like for example, if I had a function that was like f of x equals 5x to the 4th minus 3 tangent x. Its derivative f prime would be 20x cubed. Now the derivative of tangent x is secant squared x. The minus 3 in front is just a constant multiple. So that means you're just going to take minus 3 times the derivative of tangent x, secant squared x. That's it. That's the derivative. Okay? If you had a function that was a combination of just trig functions, it's the same thing. Like if I had something like y equals secant x minus cotangent x. The derivative of secant x is secant x times tangent x. The derivative of cotangent is negative cosecant squared x. So since there's a negative out front, it's going to be like minus negative cosecant squared x. So it's like plus cosecant squared x. Everybody understand why there's a plus there? The minus is a constant multiple. It carries down, but then the derivative of cotangent is negative, so you're subtracting a negative, which makes it positive. So this is the derivative. That's what you would give as your answer if they wanted derivative of that function. Does everybody understand?
Yeah, that makes sense.
So this assignment is actually on IXL. I apologize in advance, but they didn't have something that was this simple on Delta Math. It's like more steps. So we're not able to do the Delta Math assignment yet, but I did the assignment myself on IXL, and it literally took me 5 minutes. There's nothing that's too complicated. They don't even really get like this complicated. But one thing that you should be aware of is on Delta Math, I couldn't get it to do this notation. I had to do this notation.
Okay.
I mean, on IXL rather. I had to do this notation. So you got to put parentheses, secant x, and then square. Okay?
Okay.
So the way you get to this assignment is you just go to recommended by my teacher, and it should be right there. It's called like finding derivatives of trigonometric functions part 1 or something like that. Any questions? Okay, remember these homework assignments are due Monday. So if you've been using your class time wisely, then probably this is the only assignment you have, and you should be able to finish it in 5 or 10 minutes. If not, just keep in mind that it's due Monday, even though there's no school Monday.
And the IXL is 90.
The IXL, yeah, a 90 is 100. But if you go to like 88, then you'll get an 88. You're not going to get like a 98. Okay? All right.